Math 10's this example, first intro example for 1.7, solving problems involving objects. So we're talking about surface area and volume problems, and they get slightly more complicated here. To rewind back to what Math 9 had you do a whole bunch of, you had shapes and you had to find, partial areas, partial surface areas. So here's a straightforward one. We've got a square and there's a circle on top of it, and we want the area of this shaded region. Well, if you think about that logically, the shaded area should be the area of the square, subtract the area of the circle. And so we know how to find the area of a square. It's just length times width, or side times side. Area of a circle is pi r squared. So if I substitute in the appropriate values, the fact that the square was 4 by 4 and the circle had a radius of 1, I end up with 16 minus pi, which is close to 12.86 square meters. So now the kinds of questions we're going to see are, again, going to be area and volume questions where the shapes get more complicated. So we're going to determine the volume of this shape, and the shape here is a composite shape. So in other words, it's two of our shapes kind of stuck together. So hopefully you can see this, even though my drawing is far from perfect, as a rectangular prism with a rectangular pyramid kind of plopped on top of it. So the total volume, I don't have to worry about the areas of these faces and stuff like that. The volume of this is what I'm interested in, is just going to be the volume of a rectangular prism plus the volume of the pyramid that's on top. You can actually just add the volumes in this case. We do have a formula for each of those on the formula sheet. Be careful, I put extra brackets around the second h there because they aren't the same height. I'm just stealing the formulas. I just don't want you to mix up and put. So the height of the rectangular prism is 8, so it's 22 by 7.5 by 8. And you get a fairly large volume for that rectangular prism. And then for the rectangular pyramid, you have two of the dimensions are the same, like the length and the width are the same, but it had a different height. It had a 6-foot height. So 1/3, 22 times 7.5 times 6. Then it becomes a calculator question and making sure you're following your order of operations. But to the nearest cubic foot, I got that one to be about 1,650 cubic feet. But again, what's important here isn't so much the answer as it is the process of, in this kind of composite volume question, I can just add the two volumes together.